Okay, so we want to find the limit, L, find the limit first, and then use the epsilon delta definition to prove that the limit is in fact L. So finding the limit in this case is very straightforward. It's direct substitution. Could plug in 0 for x without having any issues there. So that should be the cube root of 7 times 0, which is 0. Okay, done. Now, before I move on, just keep in mind, when you're doing the homework, this is all you need to do in order to earn full credit for the problem. But on the exam, I'm not asking you to give the limit. I'm going to be asking you to show your work step by step and give the complete proof using the epsilon delta definition. So, epsilon delta definition. For any number epsilon, any positive number epsilon, there exists a corresponding delta, which is also positive, such that if the absolute value of x minus c is not 0, but less than delta, then the absolute value of f of x minus L will be less than epsilon. Okay, so here's the epsilon delta definition. Just put a box around this. Okay, so now we want to use this definition for the proof, which means we need to find a relationship between delta and epsilon. Relationship between delta and epsilon. And we're starting with epsilon, so it's for any epsilon greater than 0. So first you pick epsilon, and then there exists a corresponding delta greater than 0. So we'll start with the then statement, and we'll work backwards to the if statement. Okay, so we're going to start with the absolute value of f of x minus L is less than epsilon. And what we want to do is end up with the absolute value of x minus c is less than something. And when we transform the left-hand side from f of x minus L into x minus c, whatever the right-hand side changes into, that's going to be our choice of delta. And so our goal is to do all of this work in between. Okay, so let's see what we got. Our f of x is the cube root of 7x. Our value of c is equal to 0, and our value of L, in this case, is also equal to 0. The limit value is equal to 0. Okay, so let's plug this stuff in. F of x, the cube root of 7x minus L, which is 0, is less than epsilon. Okay, and if there's minus 0, we don't need a minus 0 there. We can get rid of the minus 0. So we can just say the cube root of 7x absolute value is less than epsilon. And we need x by itself here, so we need to get rid of the cube root. We need to get rid of the 7. So what we could do here is cube both sides. Then we'll have the absolute value of 7x is less than epsilon cubed. Okay, we're almost there. Get rid of the 7, so we could divide by 7 or multiply both sides by 1 over 7. So then we'll have the absolute value of x is less than epsilon cubed over 7. All right, and this is pretty much it. We could rewrite this as x minus 0, just to put it in the exact form of x minus c is less than epsilon cubed over 7. And now we are done with this portion. We're done with the relationship between delta and epsilon, because now we have absolute value of x minus c is less than delta. And so this is our delta. Let delta equal epsilon cubed over 7. Okay? So this is not the answer. This is not even the proof. This is just the sort of the side work. Now, the proof. So remember, this is an if-then statement. In the proof, you start here. You start with the if-then statement. You start with the if statement. It's called the antecedent. That matters. Start with the if statement, and then you have to show or prove the consequent or the then statement. So we're basically done the proof. We have all the work here. We just have to reverse the steps. So the proof will be absolute value of x minus c is less than delta, or x minus 0 is less than epsilon cubed over 7. Now I'm just reversing the steps in the proof. Or the absolute value of 7x, if we multiply both sides by 7, is less than epsilon cubed. Now we can take the cube root of both sides. The cube root of 7x in the absolute value is less than epsilon. And we could throw in the minus 0. Absolute value of cube root of 7x minus 0 is less than epsilon. And this is our absolute value, f of x minus L is less than epsilon. So here's our proof. We started with this. That implied this step, which implied this step, which implied this step, which implied this step, which was where we needed to be. Okay? So in red, so in black on the left, this is the work involved in finding this guy, the delta epsilon relationship. And the proof is simply reversing the steps. Okay, that does it for this one.